Hello and welcome to your lecture on measurement. In this lesson your objectives are to be able to use standard units of mass, length, time, money and other measures, to be able to read a timetable and use compound measures such as speed, density and pressure, as well as using ratios to find the values of missing lengths on scales and maps. And finally, to use compound measures such as rates of pay and unit pricing to solve problems in real life contexts. So hopefully it's not going to be too difficult and you'll do well on your assignments. So let's talk about units of measurement then. The metric system of units is based on tens. Okay, so here are some metric units. So these are ones that you really need to learn off by heart if you don't know them already. Now looking at length, we have the fact that 1 centimetre is the same as 10 millimetres. So that means that every time you draw a centimetre, 1 centimetre, it's the same as having 10 smaller ones inside there that are called millimetres. Okay, every time you see a metre, something that's a metre long, okay, so for example, maybe a desk or, your 1 metre rulers, within there are 100 of these centimetres. Okay, so it's better if you try and visualise it like that. If you went for a walk and you walked a kilometre, okay, 1 kilometre, you'd have to walk a kilometre, it's quite far. That's 1,000 metres. That's 1,000 of these. So you must try and visualise like that, because if you can, it'll make your life a lot easier. If we look at mass, which is kind of like weight, which is the same as weight, okay, you've been given that there are 1,000 milligrams in a gram, okay. Fair enough, but we're not always asked to remember that one. Okay, so in 1 small tiny gram, okay, which wouldn't be very much, there are 1,000 milligrams. You will use this if you are doing nursing or something like that. However, you must remember this second one here. 1 kilogram is 1,000 grams. Okay, it depends which way around you want to write it. It doesn't really matter just yet. But let's say we'd got a jug and, well, not a jug, but let's say we do have a jug or a container, okay, and it's 1 kilogram. If we filled that container to the top, it's 1 kilo. Inside there will be 1,000 small, tiny grams, okay. Now, we then need to remember that in 1 ton, okay, let's say that you've got a small car and it weighed a ton, 1 ton, that is the same as 1,000 kilograms or 1,000 of these, okay. So again, try and visualize. Then when we talk about capacity, so like litres, millilitres, things like that, again, let's say we've got a jug. Here's our jug. Not a very good jug. But that jug could be 1 litre. Okay, the top of the jug is a litre. Okay, and inside there, again, there are 1,000 millilitres. So you can kind of link this to grams and kilograms because it's similar. Now, also inside 1 litre, there are bigger measurements. And inside those bigger measurements, okay, we have centilitres. So we also have 100 centilitres in a litre. Now we must remember that if we worked out the volume of something in centimetres, so let's say we had a cuboid like this, okay, and it measured, well, I've not written it very well, 10 by 10 by 10 centimetres, and we worked out the volume, okay, we would have 10 times 10 times 10, that will give us 1,000 centimetres cubed. And we must remember that every time we get 1,000 centimetres cubed, it's the same as 1 litre. Okay? Okay, so what we're going to do is you're going to do some conversion now, and then I'm going to go through and explain how that works in a bit more detail, okay? Okay, so what I want you to do now is pause the video and have a go at these 4 questions Okay, I've put the measurements at the bottom for you, and then press play for the answers. Okay, if you've had a go at that, what we're going to do is, I'm going to explain a method that I would use in order for you to work these out easily, especially if you don't know the conversions very well. Now, you must remember the most common ones, okay? So you've got to remember that 100 centimetres is a metre. You must remember that. I'd also remember, well, all three of those I would remember. Definitely remember that one, and definitely remember that one and that one, okay? Some of the others they might tell you, especially this one here. They'll probably tell you that, okay? Now, the first one says 500 centimetres to metres. Now, I would write it like this. 1 metre equals 100 centimetres. Okay, I'm going to change my pen. 1 metre is 100 centimetres. Well, I've got 500 centimetres. Okay, so you can either use your common sense and think, well, I've got 500 of these. Okay, so that must mean 5 of these. Because every time you get 1 metre, it's 100 centimetres. Well, I've got 500 centimetres, so that must be 5 metres. However, another way to think about this is to think, if you draw your conversion like this, now we've gone through this before, and time goes at the top and divide goes at the bottom, your arrows always go in a clockwise direction. This works for every measurement, so I know this is an easy one, 1 metre to 100 centimetres, but it works for everything. It works when you're converting money as well. So for any measurement, as long as you write 1 here, the 1, and then the conversion rate there, it will work. Okay? And what this is telling me is that if I'm in metres, if I'm over here, and I want to go to centimetres, I'm going to times. And then it's telling me that if I'm in centimetres and I want to go to metres, I divide. So in this case, I'm in centimetres. I've got 500 centimetres in the question. So I know that I'm going to take my 500 centimetres and I'm going to have to divide, because I'm in centimetres, by 100. Because I always divide or times or divide by the conversion factor. The conversion factor is always the big number here. It can't be the 1 because we'd get the same answer. So it must be that big number. So 500 divided by 100 is 5. So I know I get 5 metres out of that. Okay. Right, let's look at another one. So for question B, it says 5 litres to centilitres. Again, if we're looking at our diagram, it's saying that 1 litre is 100 centilitres. Remember, I told you must write the 1 this side, okay, otherwise it doesn't quite work. Okay, all right. I'm then going to draw my arrows that are clockwise, times at the top, divide at the bottom. I am in litres. I've got 5 litres. Okay, that means I'm on this side of the diagram. 5 litres. And I want to go over to this side of the diagram into centilitres. My conversion rate is 100. So I need to times that by 100, giving me 500 centilitres. Okay, so that would be 500 centilitres. Again, I know this seems like I'm probably making it too difficult using the diagram, because you could have looked and thought, well, I know that 1 litre is 100, so 5 litres must be 500. That's fine, but I'm just trying to get you used to using this diagram because it'll make your life easier later. Okay, C. C says that 3,500 grams to kilograms. That's what it wants. So looking at our chart, I know that 1 kilogram equals 1,000 grams. Drawing my arrows, times at the top, divide at the bottom. I've got 3,500 grams. And I'm on this side of my diagram, because I'm in grams. So I need to go to kilograms, so I'm going to divide. And I'm going to divide by my conversion rate, which is 1,000. Okay, remember, it's always this side. So 3,500 divided by 1,000 is 3.5. So that would be 3.5 kilograms. Again, you can just look at the 1 kilogram equals 1,000 grams and think, well, 3,000 grams is 3 kilograms, so 3,500 must be 3.5. But again, it depends on how your brain works and how you take in information. The last one then says 25 centimetres to millimetres now. Okay, so if we're looking at our millimetres section, which is just here, I know that 1 centimetre equals 10 millimetres. Drawing my arrows, times at the top, divide at the bottom. I'm in centimetres. I've got 25 centimetres, so I'm on this side of the diagram. 25 centimetres. And I want to go over to this side and put it into millimetres. So I must times by my conversion rate, which is 10, my conversion factor, which is 10. So 25 centimetres is 250 millimetres. Okay. Right, you really need to get used to converting different measurements, okay? It's very important that you do that. So practice using these methods or using your, the knowledge that you already have, and have a go at the questions on the assignment. Okay, let's move on. Okay, so what we're going to do now is we're going to think about what type of measurements we might use for different things. So why don't you pause the video and think about what kind of units of measurement we would use to measure or weigh these things here. Okay, so let's go through some of them then. So the first thing we've got is the mass of a packet of crisps. The mass of a packet of crisps would be weighed in grams, okay? It's not small enough to be weighed in milligrams, which would be like, really small, like tablets and things like that. So we would measure it in grams. The length of a river. Length of a river, it would either be kilometres or maybe miles, depending on whereabouts you are in the world and what you're going to use. The thickness of a book. The thickness of a book we could measure in millimetres. If it was an extra thick book, we would measure it in centimetres, but millimetres is probably your best bet. The capacity of a bottle of water. Now, they tend to be measured in centilitres when you look at it on the bottle, but you could also measure it in millilitres. The amount of medicine in a spoonful. So in a spoonful, we measure that in millilitres, okay? Whereas if it was a tablet, an actual physical tablet, we'd measure that in milligrams. The width of a bookcase, we could measure that in centimetres, but we could also maybe measure it in metres. It depends how big it is. Amount of water in a pool, we would measure in litres, okay? Again, a pool's quite big, so it depends that if you'd keep it as litres or you'd measure it as volume, but litres is good. Mass of a bag of potatoes, definitely kilograms. When you go to the supermarket, you'll see how many kilos there are in a bag of potatoes. Mass of a lorry, that would be in tonnes, because a mass of a lorry would be quite big, so we'd have to measure it in bigger. The thing is, we have to change the measurements, because let's say we had a bookshelf and it wasn't very wide, okay, so I'm just going to give you an example. If we only had a bookshelf that was a certain width, we could measure that in centimetres. But if we had one that was really long, you'd get too many centimetres, so we'd probably measure that in metres instead. And with the lorry, we wouldn't really be able to measure it in kilograms because you'd get too many. So then we go up to the next one, which is tonnes. And then height of a house would most likely be measured in metres. Now, these are, the measurements that we use often, but sometimes we have to use, so these are metric measures, and it's very important to remember that, centimetres, millilitres, grams, kilograms are metric units, okay? And a lot of the time, this is what you're going to be using in your exam. However, we can compare metric and imperial units. Okay, so here are some comparisons between metric and imperial units. These are fairly approximate, Alright, they won't be exactly accurate. So the first one here says that 2.5 centimetres is an inch. So if you opened your tape measure or you took out a ruler and you measured an inch, okay, it's about that, maybe a bit bigger, 1 inch. Alright, that's about 2.5 centimetres. It's actually more like 2.54 centimetres, but we're just approximating here. Okay, so every time you measure an inch, you measure 2.54 centimetres. Now, if I said to you, I want to know what 4 inches is, 4 inches in centimetres. This is when we can write down our conversion again and we can say, right, well, 1 inch is the same as 2.5 centimetres. I can draw my conversion diagram and put times at the top and divide at the bottom. And what I'm saying is I want 4 inches. I want to know what 4 of these are in centimetres. And because I'm on this side of the diagram, I'm in inches. In order to get to centimetres, I'm going to have to times. So I'm going to take my 4 inches that I want to work out, and I'm going to times by the conversion rate, which is 2.5. Okay? Well, altogether, that is going to be 10 centimetres. So I know that 4 inches is around about, approximately, we could write approx there, 10 centimetres. So again, your conversion diagrams will come in more handy when you're doing imperial conversions, because you're not just saying there's 100 centimetres in a metre, or, 10 millimetres in a centimetre, and so on. Okay. Now then, your next one here, you've got 8 kilometres equals 5 miles. Now, they give you that one quite a lot. 8 kilometres equals 5 miles, roughly. Now, if you wanted to, you could actually divide by 5 here on both sides, okay, to give you what 1 mile would be. Okay, and if I did 8 divided by 5, it's like it's around about 1.6. Okay, 1.6 kilometres is 1 mile. So you can remember that if you want, or you can remember that. Either way, you're going to have to use it to convert. All right. Okay, so just a few others then, and these work in exactly the same way, using the same conversion chart as I've used here on the right. Okay, you have 28 grams is an ounce. Okay, so I could say, if I wanted to, that 1 ounce, OZ, we write that, equals 28 grams. And I can use my conversion chart to multiply or divide, converting ounces to grams and back again. Okay. The same here, 1 kg equals roughly 2, this is why I'm using the this symbol rather than the equals sign, because it's an approximation. 1 kilograms is roughly 2.2 pounds. Okay, so let's say I wanted to know what 2 kilograms was. I would just draw my arrows, times at the top, divide at the bottom. And I'm in kilos, so I want to go to pounds, which means I'm going to times by 2.2. Okay, and 2 lots of 2.2 is 4.4 pounds. So 2 kilos would be roughly 4.4 pounds. Now, the next one you've got here is 1 litre equals 1 3/4 pints. So you could write that as 1 litre equals 1.75. Okay, because remember, 3/4 is the same as 0.75. So you've got 1 and 3/4, so there's your 1, and there's your 3/4. And then you can draw in your arrows. And then finally, 4.5 litres equals a gallon. So remember, we have to put the 1 on this side. 1 gallon, what I might do instead is, rather than writing 1G, because you might get confused, is write 1 gallon equals 4.5 litres, because you might get confused and think it's grams. And you can, again, just draw your arrows in, times at the top, divide at the bottom, and you'll be able to convert. All right. Okay, so I hope you understand the conversions and how you convert using those diagrams. I think you'll get used to it the more you practice. Okay, let's move on then and look at some time and reading timetables. Now, it's very important that you remember that you can read or give times using either the 12-hour or the 24-hour clock. Okay. The 12-hour clock, okay, is where you have times before midday, which are AM, and times after midday, which is PM. So, for example, you get up at 1 o'clock in the morning. Let's draw a quick clock here. Okay, 12. It's easier to do it like that. And then put the 1, 2, 4, 5. Okay. Now, let's say this is 12 o'clock in the morning, 12 a.m. Okay, like the middle of the night. This is then going to be 1 a.m. This is then going to be 2 a.m., 3 a.m., 4 a.m., 5 a.m. So it's starting to get light now, maybe 6 a.m., 7 a.m. You might be getting ready for school or college or whatever, work, 9 a.m., 10 a.m., and 11 a.m. Okay, then what happens is we get to lunchtime and it becomes 12 p.m., 1 p.m., 2 p.m., and so on. Okay, I know it might sound silly that I'm explaining the clock to you, but some people really struggle with this. 7 p.m., 8 p.m., 9 p.m., 10 p.m., 11 p.m, and then back again to 12 a.m. Okay, so your times are split between a.m. and p.m. Now, if I did the same clock, okay, so your 24-hour clock now is written from 0 to 24. So if I drew that clock out again, and we did the times, let me just write them in again. Sorry, I know it's not going to be a perfect clock. Okay. And then again, let's say we got up at 12 midnight, okay, 12 a.m. We would write that as 12. 1 a.m., we'll just write it as 1. 2, we don't write a.m. and p.m. with the 24-hour clock. The reason for that is, so this would be 4, 5. In fact, it would actually sometimes have a 0 in front of it, and it's written as 4 digits. Okay, like that. 6, 7, 8, 9, 10, 11. So these are all AM. Okay, we don't say AM because it's the 24-hour clock. So it's only the 12-hour clock here, 12-hour clock, where we say AM and PM. If we're using the 24-hour clock, we would say 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 for morning. And then what happens is when it gets to 12 in the afternoon, we say 12, but then 1 o'clock turns into 13, and then 14, and then 15. And we say like 1500, 1600, 1700 hours. Okay? 18, 19, 20. And again, the more you do this, the more you get used to it. Like when I was younger, I used to work in a taxi office, and we always used to use the 24-hour clock. So I got used to it really quickly. But not everybody does, so I want to make sure that you understand it. So basically, instead of saying the PM, we just go round the clock again until we get to 24. So even though we would say 12 here, this would actually be like 2400 hours. Okay? Okay, so that's the difference between the 12 and the 24-hour clock. If you haven't already, take those notes down, draw them, because I'm going to give you some questions now. Okay, so what I'm going to do is I'm going to rub these out. So pause the video and draw those out if you need to, or take a screenshot. I'm going to rub them out and I'm going to give you some questions. Okay, right, question time. Okay, convert these times to the 24-hour clock and convert these times to the 12-hour clock. Okay, pause the video and have a go, and then press play for the answers. Okay, if you've had a go at that. So, convert these times to the 24-hour clock. So for this one, you should have got 14:42. Okay. And this one's 5:30 a.m, so we're just going to write it as 5:30. Okay, this is in the morning, so we just write it like that as the 4 digits. Converting these times to the 12-hour clock, so this is 3:27 p.m. and this would just be 7:04 a.m. Okay, so hopefully you got those right and you understand how to use the 12 and 24-hour clock. Now, what we're going to do is explain a little bit more about time, and then we're going to look at some timetables. Okay, so the 24-hour clock times can often appear on bus and train timetables, and you'll need to be able to convert between different types of units of time. Now, there's some things that you must know, which a lot of you probably will, but I'm just going to go through them anyway. There are 60 seconds in 1 minute. There are 60 minutes in 1 hour. And there are 24 hours in 1 day. There are 7 days in 1 week. There are 52 weeks in 1 year. And there are 365 days in a year, or 366 in a leap year. Now, those are some facts that you must remember. You probably know this one, this one, this one, this one. It's these last two that people forget. Okay, or at least I've heard people ask. All right, you might know them. Try and remember them, because sometimes you'll be asked questions about, John gets paid £152 a week. How much does he get paid over the year? Okay, and it's better to times that by 52. Okay, so using your facts at the top there, it says here, the timetable gives the times of some of the trains from London to Manchester. Okay, now obviously there is a question to go along with that, but I'm just trying to explain a little bit more about the timetable. So what this timetable means is, or what a few of these times mean. So first of all, we know that this is the morning. We know it's the morning because it's using the 24-hour clock. Okay, and that's saying 07:02. That's 7:02 a.m, 7:32 a.m, 8:50 a.m, and 9:40. Whereas this side, we've got some of the afternoon times. We've got 2 p.m, 2:30 p.m, 3:45, and 4:40. Okay, so again, you really must get used to using the 24-hour clock. So this one says, this means basically that the 8:50 train from Stoke-on-Trent, okay? So when there's a time next to a place, it's saying that you can get that train from Stoke-on-Trent at that time. And it goes to Manchester Piccadilly and arrives at 9:40. Okay? So it goes downwards like that. Now then, this is showing you that the 7:40 train from London Euston arrives at Manchester Piccadilly at 10:15. That's what that means. Okay, so then here, this means that the 11 o'clock, you see here, this is an 11 o'clock train from London Euston. It goes to Watford Junction, but it doesn't go to Stoke-on-Trent. It doesn't stop there. Okay, it goes straight down to Manchester Piccadilly and arrives at 1:15 p.m. Okay, 1:15 p.m, that's what that means. Okay, right, so I just wanted to go through so that you understood it a bit better. You've now got some questions. So, 2 questions there. Why don't you pause the video, have a go at those questions, and then press play for the answers. Okay, if you've had a go. Now then, it says here, Jade travels from Watford Junction to Manchester Piccadilly to attend a university open day. She catches the 7:32 train from Watford. How long should the train take to travel to Manchester Piccadilly? So, first of all, she goes from Watford Junction. So here's Watford Junction, and she leaves at 7:32. It says, how long should it take for the train to arrive in Manchester? Well, it arrives in Manchester at 9:40. So she's travelling from 7:32 all the way up to 9:40. Okay? Now, depending on how you want to work this out, you might just know it off the top of your head and be like, oh yeah, it's this long. That's fine. But what I would do if I was you is I would think, okay, well, from 7:32 to 8:32, that's 1 hour. And then from 8:32 to 9:32, that's another hour. And then from 9:32 up to 9:40, that's just 8 minutes. So altogether, it takes you 2 hours and 8 minutes. Sorry, it takes Jade 2 hours and 8 minutes. Okay? So you can use Numberline to help you. You could have probably just worked that out in your head as well. Some of you will have. I'm just trying to give you different methods to use to help you work things out easier. Okay, question B says, Colin arrives at London Euston at 12:42. How long should he have to wait for the next train to Manchester? Okay, so let's have a look. It says he arrives at London Euston, which is at the top here, at 12:42. Now the only trains that leave from London Euston are 7:02 a.m., 7:40, 11 a.m. and 2 p.m. Okay, so he's arrived at 12:42, so he can't get that train, he can't get that one, and he can't get that one. He's going to have to wait until the 2 o'clock. Okay, so if I put 1400 there, 2 p.m. Okay, he's going to have to wait from 12:42 up to 2 p.m. Now, what you could do here is you could say, well, from 12:42 to 1 o'clock, 1 p.m. Okay, 1 p.m. That's going to give me 18 minutes. All right, so I could count up if I wanted, 42, and then count all the way up to the next hour. Okay, which is 18 minutes, because it's 20 minutes, isn't it, from 12:40, and you've got 2 extra. So you need to take 2 off. That's 18 minutes, and then from 1 o'clock till 2, that's 1 hour. So he's going to have to wait 1 hour and 18 minutes. Okay? Alright, so I hope you got those 2 correct then when you had a go. Alright, let's move on to doing something a little bit different, and we're going to move on to doing maps and diagrams now. Okay, so now, maps and diagrams. Sometimes you'll get questions without any maps or diagrams to look at, and scales are often used on maps and diagrams, okay, and they're usually written as ratios. So if we look at this example question, it says some students are taking part in a fun run for charity. They are running between marker A and marker B, okay, and it says the scale on a road map is 1 to 25,000. Marker A and marker B are 60 centimetres apart on the map. Work out the actual distance between them in kilometres. Okay, so what I would do here is I would actually draw a little bit of a diagram for myself. So it's telling me that they're going from marker A to marker B, and that is 60 centimetres. Okay, now it then tells me that the conversion rate is 1 to 25,000. And what you need to assume that means is that for every 1 centimetre on the diagram, it's 25,000 centimetres in real life. Okay, so we need to do, again, you could use your conversion for this as well. You could say 1 to 25,000. And you could draw your arrows in and put times and divide. Okay, this is 1 centimetre is the same as 25,000 centimetres in real life. We've actually got 60 centimetres on our diagram, so we're this side, 60 centimetres. And in order to get to the real life version, we have to times by 25,000. Now this would actually be, it'd probably be a calculator paper, because you've got to multiply by 25,000. But that is possible, okay, without a calculator, by taking off zeros and doing 6 times 25. And then adding zeros back in. You should already know how to do that. We've gone through that quite a bit. Okay, I'll just show you that quickly here again. So if I wanted to do it without a calculator, 60 times 25,000, what I would do is I would do 6 times 25. 6 times 25, okay, is 150. You should be able to work that out because you should know your 25s really. 25, 50, 75, 100 and so on. And then I've just got a 0 there and 3 zeros there. That's 4 zeros. 1, 2, 3, 4. And then what I would do is, in order to be able to write that number properly and to understand it, I'd put a comma in every 3 places. So every 3 places, there's a comma. So 1,500,000. Okay? So that's without a calculator. Obviously, if it was with a calculator, you would have easily gotten the answer. Okay, so now I know that in real life, I'm going to write this up here, real life, it's 1,500,000 centimetres. However, our answer wants it in kilometres. So, let's think about that. I'm just going to move this. In kilometres, I know, let's think about what I know. 1,000 metres is a kilometre. Okay, now I'm still in centimetres here, so I'm not quite in metres. But I also know that 100 centimetres is a metre. So what I'm going to have to do is I'm going to have to convert this to metres first. Okay. And then convert it to kilometres. Because there is 100 centimetres in a metre, I just need to, again, I can write it like this, 1 metre equals 100 centimetres. And just remind myself that if I'm in centimetres, which I am, okay, which is here, I'm going to divide by 100. So I'm actually going to divide this number by 100 to put it into metres. Remember, when you divide by 100, you can just take off 2 zeros. Okay. So now I am left with 15000. That's 15,000 metres. Okay, because I've taken off these 2 zeros. Now what I'm going to do is put it into kilometres. So what I'm going to do is I'm going to take away that diagram. And I'm going to say, well, I know that 1 kilometre is 1,000 metres. Draw in your arrows, times, divide. If I'm in metres, which I am, I'm on this side, and I want to get to kilometres, again, I'm going to divide. Okay, and I'm going to divide by 1,000. So I'm going to divide this by 1,000 now. And to divide by 1,000, I just take off the last 3 zeros. Or you could say move it back 3 decimal places. And you're just left with 15. So you're left with 15 kilometres. And that would be the answer to your question. So these kinds of questions involve you converting between measure using those conversion factors. Okay. So I know it seems a little bit difficult and quite a lot to do in one go, but hopefully that's made sense and you can understand how to do that later. Let's have a look at another example question. Right, this one says that a house plan has a scale of 1 to 30. If, capital I, the width of the house on the plan is 64 centimetres, what is the width of the actual house? So why don't you press pause and have a go at that one, and then press play for the answer. Okay, if you've had a go, again, you can draw yourself a little diagram, and it says that there is a width of a house, so it's up to you if you wanted to draw a house. There you go, little house. And the width is 64 centimetres on the plan. So on the drawing, it's 64 centimetres. It's also telling us that the conversion is 1 to 30. Again, you need to assume that that's 1 centimetre is the same as 30 centimetres in real life. The reason it's centimetres is because they're measuring the house in centimetres. If they measured this in metres, we would then have to assume that it's 1 metre on the plan, 30 metres in real life. Okay, now, what it's asking then is to work out what that is in real life. So, you've got your 1 centimetre equals 30 centimetres. And we can draw our conversion arrows in. Times at the top, divide at the bottom. I have got 64 centimetres to convert, which means I'm on this side of the diagram. If I'm on this side of the diagram, I need to times to get to the real life version. Alright, so I need to do 64 centimetres, because that's what I've got, and I need to times that by 30. Now, if this was a non-calculator paper, which is unlikely, you could do 64 times 3 using whatever method you know. Okay, so you could do that method, or you could do 64 times 3. It's up to you. Okay, and so I'm just going to do this one. 4 times 3 is 12. Don't forget to carry your 10. And 6 times 3 is 18. Plus the 1 is 19. Okay, so that's only 64 times 3. So we just need to add a 0 on the end of that, because it's actually 64 times 30. And that's it. Okay, so that's centimetres. Now, that's fine. It's not asked us to change it to anything. But if I wanted to put that into metres just to make it look a bit nicer, I would think, okay, well, I've got 1,920 centimetres, and I know that 1 metre is the same as 100 centimetres. And if I use my conversion diagram again, I could put that 1,920 into metres. So I'm on this side of my diagram, because I'm in centimetres, and to get to metres, I'm going to have to divide by the conversion rate, which is 100. So if I divide that by 100, it gives me 19.2 metres. And it's so obviously the question didn't ask, but just thought I'd go through it anyway. Most of the time it will ask you to do something like that. All right. Okay, so that's all you have to do for like the ratio style questions like that. It's pretty obvious once you read the question what it is you've got to do. You're just going to convert this to the real life answer. Okay, now then, let's look at another one. This one does involve a diagram. So, this is an exam question. It says, here is a map. The map shows 2 cities, Leek and Milton. Use the map to calculate the actual distance from Leek to Milton. Okay, and then it says, Sandville is an equal distance from Leek and Milton. How far is Sandville from Leek? Now, in this case, I can't actually measure this on the computer. But what you need to do is you would need to draw a line from here to here first. Now, it'd be difficult for you to have a go at this one as well yourself, so I'm just going to go through it. Now, you would have to draw that line, as I've already said. So you'd get your ruler out, and you would draw that line, okay? And you would then measure it using your ruler. So measure the line. Okay, I'm going to put here, number 1, measure the line. Okay, I'm going to, for this example, say that it's 6 centimetres long. That line is 6 centimetres. It says, use the map to calculate the actual distance, and it gives us this scale. Okay, 1 centimetre represents 30 miles. Okay, so they're not giving it you as a ratio, they've told you that 1 centimetre on the map represents 30 miles. So from that, I could draw my arrows in, times at the top, divide at the bottom. And I've got 6 centimetres. So I'm on this side of my diagram. So I'm going to take my 6 and I'm going to have to times it to get to my real life answer by 30. Okay. So 6 times 30. I could do 6 times 3, which is 18. And then I can add a 0 to the end. So that's 180 miles. And that's what would go in there. And you get 2 marks for it. The second question says that Sandville is an equal distance from Leek and Milton. Equal distance. How far is Sandville from Leek? Okay, so what that means is that Sandville would be about there in the middle. Okay, Sandville. Great name. Okay, so if it's right in the middle, all I would do is I would do 180 divided by 2. Okay, 180 divided by 2 is 90. So it's just 90 miles. That would go there and you get an extra mark for that. Not too bad then, really. Okay, I think you can understand that quite well. Okay, so let's move on. We're going to have a quick look at compound measures then now. Okay, so compound measures. Compound measures involve two other measures of different types. You need to understand and be able to use compound measures related to speed, pressure and density. So when I say speed, I mean speed, distance and time. And you need to work in steps when you convert between these measures, okay? So first of all, let's look at speed, distance and time. That's your first one. So I've said speed here, but speed, distance and time is one. Then you've got another one and then you've got one more. We'll go through them as we get there. Speed, distance and time. So units of speed include meters per second, kilometers per hour, miles per hour, okay? Now, you might be asked to work out the speed when given the distance and the time. You might be asked to work out the distance giving the speed and the time. And you might be asked to work out the time giving the speed and the distance. What you need to do is try and remember and learn this triangle, okay? I remember it like this bottom bit here is like sit, because you've got a line in the middle that looks like an eye. So sit, and then down. It's at the top, which it depends how you want to remember that, but that's how I remember it. Sit is along the bottom, and then you can put D at the top. Sit down or sit and then distance at the top. It's up to you. And what you need to do is, when you're asked to do different things, okay, so for example, if you're asked to work out the distance, we cover the distance over, okay, which then means you do speed multiplied by time. Okay, so distance equals speed multiplied by time. If you're asked to work out the speed, we cover the speed over, in which case you would then do distance divided by time. And then finally, if you're asked to work out the time, we cover over the time and we do distance divided by speed. Okay, so that's basically all you have to do. Let's have a look at some examples. Change 80 kilometers per hour into meters per second. Okay, well, first of all, for this one, you don't actually need the speed, distance, time triangle. We're not being asked to change anything else. We're not being asked to find anything. We're just being asked to change 80 kilometers per hour into meters per second. So let's first of all, if you want to pause the video and have a go at this, please go ahead. Okay, if you've had a go, let's first of all concentrate on the 80 kilometers bit. 80 kilometers. I know kilometers, yeah? So 1 kilometer is 1,000 meters. And I need to turn it into meters. So again, if you want to draw in your conversion chart, you can. And if I'm going from kilometers, which I am, I'm going to take my 80, I need to times that by my conversion rate, which is 1,000, okay, to give me 80,000 meters. Okay? Now, all I've done is change my kilometers. So far, I've still got 80,000 meters per hour. What I want to do is turn that into per second. Now remember, I gave you some information earlier, and I know that there are 60 minutes in 1 hour, and there are 60 seconds in 1 minute. Okay, so the first thing I need to do is I need to take my 80,000 meters per hour, and I need to divide that by 60. Now, the reason I'm dividing divide by 60 is because if in a whole hour I'm travelling 80,000 metres, then per minute is going to be smaller. So I'm going to divide by 60. So how many times, how much am I going to travel in every minute? So if I do that on my calculator, it gives me 1,333.33. And then what I would do is, to get it into seconds now, so that's metres per minute. Okay. And then what I would do is I would do that again. Take my 1,333.33 recurring, and I would divide by 60 again, because I want to know how much it is per second, giving me 22.22 metres per second. Okay. Okay, so that is converting using this time here. Again, you might want to practice that a little bit, because it can get a bit tricky. Okay, let's have a look at another example. So, a car travels 80 kilometres in 1 hour and 20 minutes. Find the speed in kilometres per hour. Okay, again, if you want to pause the video and have a go at that first, you can use your triangle now. And then press play for the answers. Okay. So, the first thing you've got to remember is here it's telling you 80 kilometres. That's the distance. Here it's telling you 1 hour 20 minutes, that's the time. We need to be very careful with time. Okay, we can't just put 1 hour 20 or 1.2. Okay, so we've got to work out the speed. So if I've got to work out the speed, I get rid of that, I cover it over, and I have to do distance divided by time. So distance over time. Okay, speed equals. Okay, so the distance is 80 kilometres. And the time we must write as a decimal. Now, we can't just write 1.2. That's not correct. We need to remember that if we look at a clock, okay, a clock when split into 3 like this, is 20 minutes every third. Every third of a clock is 20 minutes, okay? That means that 1 hour 20 minutes is 1 hour and a third. You must remember that a third first of all is 0.33 recurring. Okay, so we'd actually have to write this as 1.33 recurring. Okay, now obviously all I did, I mean, again, you can also think of it like, well, it's 20 minutes out of 60, okay, which again is a third, all right, just to remind you. And then, because we've cancelled down, and then you need to remember what the decimal of that is. If it was something like 50 minutes, you could write 50 out of 60, which is 5/6. And then if you needed to, you can do 5 divided by 6 on your calculator to give you the decimal, okay, which is 0.833 recurring. You must turn it into a decimal first. Just write the number that's remaining out of 60. Or you could have done 80 out of 60 because it's an hour and 20 minutes. Okay, and that's 80 minutes, which is 8 over 6, which is 4 over 3, which is still 1 1/3. Alright, which is why I've got this 1.33 there. Okay, I hope that wasn't too confusing. Hopefully you're okay with fractions. We have gone through them quite a lot, so go back to the video if you're not sure. Okay, so again, any time given to you must be written as a decimal. So if it was 1 hour and 40 minutes, okay, you can say, well, that's 1 whole 1 and 40 out of 60, which is 1 whole 1 and 20 over 30, which is 1 whole 1 and 2 over 3. You can then put the 2 over 3 into your calculator, and 2 divided by 3 is 0.66. So to write that as a decimal, it'd be 1 whole 1.66. recurring. Okay, because 2/3 is 0.66. Right, so we have now got our distance, which is 80 kilometres, over our time, which is 1.33 recurring. Now you can put that into your calculator now, and you can do 80 divided, and you can type lots of 3s, or you can use the button on your calculator that looks like this. And you can put 3 in there. Okay, that'll help you. Anyway, if you do that on your calculator, you will get about 60.00000002. Okay, so all we would do is say that is 60 kilometres per hour. And you're done. That's using your speed, distance, time triangle. All right, let's do one more. Okay. Josie is driving her car at a speed of 70 miles per hour. Audrey is driving her car at a speed of 120 kilometres per hour. Given that 5 miles equals 8 kilometres, who is travelling faster? Now, because you're using this conversion factor here, it might be a little bit tricky, but pause the video and have a go and then press play for the answer. Okay, if you've had a go at that, you've either got to convert Josie's speed to kilometres per hour or Audrey's speed to miles per hour. So what I'm going to do is I'm going to convert Josie's speed. Okay, so Josie's speed, and I'm going to convert this to kilometres per hour. I don't actually need to use my triangle because they're both already doing a speed. I haven't got to convert anything. I haven't got to work out distance or time. All I've got to do is take Josie's speed, okay, which is 70. And earlier on, what I did say was that if you wanted to, you could say, well, if 5 miles is roughly equal to 8 kilometres, and then I want to work out what 1 mile is, I can divide both sides by 5 to work out 1 mile. And it'll give you roughly 1.6 kilometres. Okay. So if I wanted to, I could do 70, and I could times that now by 1.6. Okay. If I do that, it gives me 112. So that's 112 kilometres per hour. Okay. Now, if you don't remember this, what you can do is write it as 70 times by 8/5. It's the same because technically what you're doing is you're dividing by 5 still, like I did here. But it might just remind you. And then you can either do 70 divided by the bottom times by the top, which is what we normally do when we find fractions of amounts, or you could then do the 8 divided by 5, which is your decimal version, which gives you the 1.6. Okay, so then you would end up doing the same thing anyway. So it's 112 kilometres per hour. Okay, just depends how you want to write it out. And then, because it's 112 kilometres per hour, we know that Audrey is travelling faster. Travelling the fastest at 120 kilometres per hour. Now, if you wanted to do it the other way and you wanted to work out Audrey's speed, you would actually just take Audrey's speed, 120 kilometres per hour, and you would just divide by 1.6. Okay, because then 1.6, which gives you 75 miles per hour. And she's still going, obviously she will be, it still shows that she's going quicker. You're just doing the opposite. Okay, right then, let's have a look at density, mass and volume then. So density is the mass per unit volume of an object, okay? So that's weight per unit, Alright, and we can use the formula triangle, this one, to work out density, mass or volume depending on what you're being asked. Now this works in exactly the same way as the speed, distance and time triangle. Okay, so for example here, I've got a question. Find the density of an object with a mass of 600 grams and a volume of 50 centimetres cubed. So the same applies. If you're trying to work out one thing, you cover that over. Now it says here that we're trying to work out the density. Okay, that means we cover the density over and we're going to do mass divided by volume. Okay, so density equals mass over volume. So that means then density equals 600 grams over 50 centimetres cubed. Don't actually need the units. So again, depending on whether this is a calculator paper or not, we're going to do 600 divided by 50. If you haven't got a calculator and it's on a non-calculator paper, you will just work out how many 50s go into 600. Okay, so you should be able to work that out quite easily, which is 12. And what we do is, because this is in grams and this is in centimetres cubed, we say that our answer is grams per centimetre cubed. So for every centimetre cubed of volume, there are 12 grams of density in it. And that's it. That's all you have to do to work that out. Not too bad, hey? Let's do one more of those. Why don't you pause the video and have a go at this one? Two solids each have a volume of 2.5 metres cubed. The density of solid A is 320 kilograms per metre cubed, and the density of solid B is 288 kilograms per metre cubed. Calculate the difference in the masses of the solids. So pause the video and have a go, and then press play for the answers. Okay, so first of all then, let's work out what you've got to do. So it says the difference in the masses. So if you've got to work out the mass, that's what we get rid of. And we need to do density times by volume. So if we do solid equals density times volume. Okay. Now they both have a volume of 2.5 metres cubed, so that's easy. Okay. And then the density of A is 320 kg. Not that it matters when you're doing the calculation. So the first thing we're going to do then is 320 times 2.5. And that gives us 800 kilograms. Okay. Now if we did solid B, we'd do exactly the same. Density times volume. Again, the volume's the same, 2.5, but the density this time is 288. So if we multiply those together, that gives us 720 kg. And then we just need to work out the difference. The difference is 800 take away 720. So we're just working out the difference between these two final values. And that gives you 80 kg. Okay? Because it says what's the difference in the masses. Masses is weight. And remember, if we're talking about kilograms here, that's the weight. Okay? So 80 kilograms. All right, not bad. Okay, let's just do one more type of triangle that you've got to remember. Oh yeah, sorry, before we move on. Your triangle here is your mass over density and volume. I told you how you could remember that. For speed, distance and time. I haven't got one for remembering this, but if you want to, again, you could say, if you like, the D and the V are on the bottom and then M is on the top. So division, depends how you want to remember that. Okay, that's up to you. Okay, so then let's do one more type of triangle. So this is your pressure, force and surface area triangle. So pressure is defined as force per unit area. How much force is there on 1 centimetre squared, for example? So here is your triangle for this. Again, you could remember that as path or FAP, or whichever way around you want to remember it. As long as you remember PA goes on the bottom, PA, and then PAF, F is the end, so it goes at the top. Again, it's up to you how you want to remember those. Alright, so here is a question. So again, you're just going to use exactly the same method as we did before. A force of 17 newtons acts over an area of 5 meters squared. What is the pressure? So I've only got one example of this because it's not too difficult. But if we're trying to work out pressure, we cover it over. If we cover it over, we're left with force over area. Okay, force over area. So pressure equals force over area. So it wants to know the pressure. The force is the newtons. Okay, so let's write that down here. Force equals newtons. And then the area is obviously whatever's written in meters squared. Okay, so I'm not going to write 5 actually. I'm just going to write meters squared there. Because it doesn't matter. That will be the area. Remember, area is always written in something squared. It could be centimeters squared, whatever. But in this case, it's meters. So the force is 17 and the area is 5. And all we do is we divide, because that line means divide, remember. So 17 divided by 5 is 3.4. And remember, because we're in newtons and we're in meters squared, we say it's newtons per meter squared. And that'll be your answer. And that's it. That's all you have to know how to do. Okay. So the last thing we're going to look at is rates of pay. And this is fairly easy. You'll probably get this quite easily. So first of all, a rate is also a compound unit. It tells you how many units of one quantity there are compared with 1 unit of another quantity. And for example, in this case, rates of pay. Rates of pay is the amount of money you get paid per the time that you do. So for example, Fiona is paid £502 per week. Each week she works 40 hours. What is her hourly rate of pay? Alright, pause the video and have a quick go, and then press play for the answer. Okay, if you've had a go at that, it's not too difficult a question because it's telling you here what you need to do anyway. And also, if you've got a job, you'll be able to work out your weekly, your hourly pay. So if you work at, if you earn £502 per week, and you work 40 hours a week, then it's obviously going to be 502 divided by 40. Okay. And if you do 502 divided by 40 on your calculator, it comes out with £12.55. So that's how much Fiona gets paid per hour for working her 40-hour week. Okay, another one then. An electric heater uses 20 units of electricity over 8 hours. What is the hourly rate of electricity usage? Again, similar kind of question. If you want to have a quick go at doing that, go ahead. Okay, so for this one, again, it's saying that they use 20 units for 8 hours. So to work it out, we do 20 divided by 8. Okay, and that's 2.5 units per hour. So as before, she earned £12.55 per hour. Okay, so we can still say that the pounds is a unit. It's still units per hour, but this time it's just in pounds. Whereas here, because it's in units of electricity, we would just put units per hour on the end. Okay, last question, and we are done. Water empties from a tank at a rate of 1.75 litres every second. Okay. It takes 10 minutes to empty the tank. How much water was in the tank? Okay. Now, it tells us here that it's 1.75 litres per second. So just think about that. Pause the video and have a go, and then press play for the answer. Okay, if you've had a go at that, It's telling us that it's 1.75 litres every second, and it says it takes 10 minutes to empty the tank. So let's turn that 10 minutes into seconds. So 10 minutes times by 60 seconds in a minute equals 600 seconds. Okay. It then tells you that over those 600 seconds, it releases 1.75 litres every time. So that's going to be quite a bit of water. So we need to multiply those together to work out how many litres of water there were. It's over 600 seconds and it releases 1.75 litres every second. If I multiply that together, it's 1,050. So it'd be 1,050 litres in the tank. Alright, done. Okay, so that was quite a lot in that lesson for measurement. You really must make sure that you can convert between measure. If you need to watch this video again, please do, just to go over the conversions, because there was a lot of conversion in there, which is really useful. You need to know the difference between the 12 and 24-hour clock, because you need to be able to convert between time. And you need to learn your speed, distance and time triangles. So not just speed, distance and time, but also the pressure and the density one as well. So there's 3 to learn. Make sure you learn them off by heart and you practice, and I look forward to seeing how you do in your assignment. Okay, let's look at some conversion graphs then now. Okay, so let's just have a quick look at this question. I'm just going to show you a couple of questions on conversion graphs so that you can understand how to use them and answer the questions in your assignment. So this graph says that it shows the conversion from pounds to Thai baht, which is just another currency in Thailand. So, the question then that it's going to give you here is use the graph to calculate how many Thai baht is equal to £80. So all you need to do is you need to go to the £80 mark, which is just here on your graph. It must be the pounds section. Pounds is shown at the bottom. Okay. And when you do that, we can go straight up to that conversion line, and these lines will be drawn for you the majority of the time. Okay, and then you'll go across to the Thai baht section. As you can see, £80 is about equal to 3,600 Thai baht. Okay. Now, if we had to do that for £115, we would then go across to the £115 mark. We would go up to the line. Oh, sorry, that's done that wrong. That's £105. £115 would go up here to that line there. And we would then go across just there. I'm not doing it very well here because I'm using my freehand. But it would be about 5,000 and maybe £150. So ignore that second red line, that's not quite right. So it would be 5,000, wouldn't quite be 250 because that would be in the middle of the line. So 150, let's say. Okay, all right, so we can use our line on our conversion graph, the diagonal line, in order to work out different measurements. Now, it might then also say to you how many pounds are equal to 750 Thai baht. In this case, we need to start on the Thai baht side of the graph, and we would go across from £750, which is just there where the blue arrow is. We'd go to the line, the diagonal, and we would go down to pounds. So we would end up with about £17 there. And then 3,000 Thai baht, again, we'd start at 3,000 just here, and then we'd go down to pounds, and that looks like it's about £68. Okay, so using conversion graphs aren't too difficult to convert between money or anything else for that matter. Now, another question here that you might get asked is, Keith has 3,200 Thai baht and Rufus has £65. Who has the most money? So I'm just going to rub out that line that I drew and some of my markings just to make it easier to see. And we can see that, if I just take my pen off, in the green, we're going to work out 3,200 Thai baht, which is about £70. Okay, so Keith has £70, which means he has more money because Rufus only has £65. Okay? Okay, not too tricky at all then. Now, sometimes you might be asked to draw the graph. Okay, so why don't you pause the video and have a go at drawing this graph, and then press play and I'll show you how it works. Okay, so what happens here is we need to have the correct axes drawn. Okay, so I've drawn those just there, and then along the bottom there I've put the hours worked, and up the side we've got the pay. Okay, now that pay, I don't know if you can see that just because the way it's drawn, goes up to 400. Now I know this looks a little bit tricky, but you are going to have to estimate a little bit here because obviously we've got some decimals. What we're looking for is to try and get a nice straight line. So for £20 we have £73.60. Okay, and I've just put a little blue dot there, but I'll draw it in orange so you can see. £40, £147.20. £60 is £220.80. For £80 it's £294.40, and for £100 it's £368. So again, we're trying to get quite a nice straight line. So try and make sure that when you are, trying to estimate as much as possible, especially for these decimals, you are creating a straight line though. Okay, don't panic if you're a little bit out. We're estimating it here, and then you'll be asked to answer the questions. So how much do you get paid for 50 hours? Okay, so we could go to the 50-hour mark, which is just there. We go to our diagonal line, go across, and you get paid £185. For 35 hours, we'd go to the 35 mark, go across to the pay, and that gives us £127. Now the next bit says how many hours do you have to work to earn £200 or £275. Now if you've drawn your graph, you should be able to work this out. Okay, so if you do want to have a go at any of these questions, just pause the video and do that. Okay, so for £200, we go from £200 and we go down to the hours. And it looks like it's about £55 there. We then have £275. So there's our £275 mark. Go down to the line and it gives us 76 hours. Okay, so hopefully you feel confident using conversion graphs now. Now, there is one more here if you'd like to have a go at this. It says the table below shows the amount of money made on sales of football shirts. Then it says use the table to draw a conversion graph. And then use your graph to answer the questions. How much is made from selling 90 t-shirts, 175 shirts, and how many shirts need to be sold to make £5,000 or £6,400? Okay, so if you've got some graph paper, you can have a go at doing that and then press play for the answers. Okay, so here is the conversion graph that I've drawn for that. So hopefully you were able to get something very similar. Okay, got shirt sales on the bottom and revenue on the top. And then we've got the questions. How much is made from selling 90 shirts? So we can go up at 90 and across, and it's about £4,000. Okay. 175 shirts. £7,600. Okay, so just make sure you're getting the correct section on your graph. This one probably could have come over a little bit more, but anyway. How many shirts need to be sold to make £5,000? So we're going to start on the £5,000 mark this time, go across and go down, and you need to sell 114 shirts. And then to make £6,400, we go across to the line and down, giving us around about 147 shirts to sell. Okay, so I hope that was clear then, and you understand how to use those conversion charts. Now there is one more type of conversion chart that you might have to use, and that's converting miles to kilometres. So it says here that the table below shows some conversions from miles to kilometres. You're going to have to do exactly the same, draw the graph and answer the questions. So again, if you've got some graph paper, have a go at that and then press play for the answer. Okay, here is the graph for that. So we've got miles at the bottom and kilometres on the side. Now, all we need to do here is, hopefully you've managed to use that table to draw this nice diagonal line and we can answer the questions. Now, most of the time you'll be given these charts and you just need to answer the questions, okay? So don't panic too much. How many kilometres is 7 miles? So we can go to 7 miles on our grid and across there, and that gives us 11.2 kilometres, okay? Now, the next one is 19 miles. So we're going to go to 19 miles on our grid, across to kilometres just there, and that gives us around about 30.4 kilometres. And then for C, it wants us to do it the opposite way round, so 13 kilometres would work out to be about 8.1 miles, and 38 kilometres at the top there would work out to be around about 23.75 miles. Okay? Right then, so those kind of questions are very, very common. You'll just have to be able to use the graph to convert and then answer the questions. Okay, so hopefully you can use standard units of mass, length, time, money, and other measures. You can read a timetable, and you can use compound measures such as speed, density, and pressure. You can also use ratios to find values of missing lengths on scales and maps, and use compound measures such as rates of pay and unit pricing, which is what we've just done, to solve problems in real life. Okay, that looks like you've done quite a lot today, and hopefully you've understood everything. So well done, and I look forward to seeing how you do on your assignment. I'll see you very soon.